In this video, we are going to discuss how to calculate the radius of the circular orbit followed by a charge particle as it moves inside a magnetic field. We know that whenever a charge particle is moving inside a magnetic field, it experiences a force. And if this charge particle enters perpendicular to the magnetic field, the magnetic force causes the particle to move along a circular path inside the field. We are going to discuss how to calculate the radius of this circular path. So here the question says, the Earth is showered with particles from space known as muons. They have a charge identical to that of an electron, but are many times heavier, with mass m equals 1.88 times 10 to the power negative 28 kilogram. Suppose a strong magnetic field is established in lab with B equals 0.5 Tesla, and a muon enter this field with a velocity of 3 times 10 to the power 6 meter per second at right angle to the field. What will be the radius of the muon's resulting orbit? So here in this question, I have a particle called muon, which has a charge identical to that of electron. So we write Q for the particle to be equal to negative E, where E is 1.602 times 10 to the power negative 19 coulomb. And this E is the elementary charge of electron and proton, which is a constant. Then we have the velocity of the particle to be equal to 3 times 10 to the power 6 meter per second. Its mass m is 1.88 times 10 to the power negative 28 kilogram, and magnetic field B is 0.5 Tesla. Since the charge particle enters at 90° to the magnetic field, we know it will follow a circular path. And whenever an object is moving along a circular path, it requires a centripetal force that will keep it within its circular orbit. For our problem over here, this centripetal force is given by the magnetic force. So I can write centripetal force Fc is equal to the magnetic force Fp. Centripetal force is given as mv squared over r, and force due to magnetic field on the charged particle is qvb sine theta. Theta over here is 90, so sine 90 will be 1. So I can write the magnetic force as just qvb. So we get mv squared over r to be equal to qvb. Now we can rearrange these to write in terms of r. So let us first cancel the v over here and one v from here. I get mv over r equals qb. So either you can use shift solve over here to calculate the value of r, or rearrange this term to write in terms of r. We get r to be equal to mv over qb. Now let's substitute the values to calculate r. Mass of the muon is 1.88 times 10 to the power negative 28. Velocity is 3 times 10 to the power 6. Over charge of muon, I will only take the magnitude of the charge and not the sign. So magnitude is just E, which we write as 1.602 times 10 to the power negative 19. And magnetic field is 0.5 Tesla. And when you solve this, you get the radius of circular path to be equal to 7.04 times 10 to the power negative 3 meter, which you can write as 7.04 millimeter. Now let's discuss another question. Here you have an electron with energy equal to 4 times 10 to the power 2 electron volt, and an electron with energy equal to 2 times 10 to the power 2 electron volt, trapped in a uniform magnetic field and move in circular paths in plane perpendicular to the magnetic field. What is the ratio of the radii of their orbits? So here in this question, you have two electrons, one with kinetic energy, which we will write as K1 of 4 times 10 to the power 2 electron volt, and the other with kinetic energy K2 of 2 times 10 to the power 2 electron volt. Both of them are trapped inside a magnetic field, and are moving in circular path. And we need to find the ratio of their radii. So we need to find what is R1 over R2 if they are both moving perpendicular to the magnetic field. So again, if the electron has to move along a circular path inside the magnetic field, it requires a centripetal force. And this centripetal force is given by the magnetic force acting on the electron. So we can write centripetal force needed is equal to the magnetic force. Centripetal force can be written as mv squared over r, which is equal to qvb sine theta. Theta over here is 90, so we can just write this as qvb. So I get mv squared over r equals qvb. So cancel off the v from here and one v from here, and you get mv over r equals qb. We rearrange this to write in terms of r. So I get radius r to be equal to mv over qb. Now, since in the question they have given us kinetic energy, I'm going to write velocity in terms of kinetic energy over here. We know the relationship between kinetic energy and velocity. K is half mv squared. So I can rewrite v as v squared will be equal to 2k over m, or v will be equal to square root 2k over m. So now let's substitute for velocity in this expression for r. We get r equals m over qb into the velocity, which is square root 2k over m. I can cancel root m and root m from here and rewrite this as r equals square root 2km over q. Now for the electron given in the question, their masses are same, the charge on electron is same, and the magnetic field in which they are moving is same. The only quantity that is changing is their kinetic energy. So when I take the ratio of their radii, there will be only a change in their kinetic energy. So I can write R1 over R2 to be equal to, we write the same expression as it is, square root 2k1 m over qb. And for R2, again same thing, square root 2k2 m over qb. So only the kinetic energy values will be different for the two electron. The other terms remain the same. And since the value of other terms is same, we can cancel them off, and you will be only left with square root k1 over square root k2, which is root k1 by k2. Now let's substitute to get the ratio. Square root k1 is 4 times 10 to the power 2 electron volt, and k2 is 2 times 10 to the power 2 electron volt. And when you solve this, you get the ratio of radii to be equal to 1.41. And since it is a ratio, there is no unit.